Another variation of this that you will see on next class's quiz is I'll give you a triangle X, Y, Z, or whatever the three vertices are, and I'll say, hey, this is 10, this is 12, this is 21. List the sides and angles from least to greatest. So same exact concept, but now rather than having the angle measurements, you have the sides. And so the largest angle in this triangle would be what? Angle Y. Angle Y. Because it opens up to the largest side. Okay? There is a way for us to figure out the angle measurements, but we're not there yet. Okay, so I'm not going to ask you for the exact angle measurement. It's just identifying which one's bigger and smaller. From there, we've got the hinge theorem. Now, this hinge theorem, this is going to take a while to jot down. And I apologize for that, but there's this, you got to set up this scenario. Now, when you hear the word hinge, what do some of you think of? A door hinge, right? I'm just going to pick up where you left off the notes. Just taking notes. Yeah, a door hinge, right? So I want to talk about this theorem first, and then we can kind of unpack it. Because the theorem itself is pretty lengthy, because you have to set up the situation. Now, the hinge theorem, put very basically, you have two triangles. And those two triangles have two congruent segments. Okay, so let's start drawing a picture about this. You don't have to draw this yet. We're just kind of talking through this. Let's say that segment's congruent to that segment, and that segment's congruent to that segment. But let's make this a little bit. Well, if I added one more segment here, and here, I would have two triangles. So I've got two triangles with two congruent sides. What we're going to be investigating is the angle that's created by the two sides that are congruent in the two triangles. We're going to be investigating that angle. Now, let's say this is triangle A, B, C, and this is X, Y, and Z. I try to make it so, I'm trying to make it look like angle A was bigger than angle Z. Does it kind of come off that way? Okay. Well, we're going to pretend that right here, this is where that hinge is. And right here, that's where the hinge is. And just like how a door works, it's closing, opening, and shutting. And because I can create, come over to this door right here, I can create different triangles. I cannot change the dimensions of this door frame. So I'm going to pretend that that's one of the sides of my triangle. I can't change the length of the actual door itself. So I'm going to say that's the second segment. Well, if I put this right here, the frame, the door, and then the opening, that creates a triangle. You understand what triangle I'm talking about? Being created by this door, this situation right here. Okay, so some of you are looking at me like I am an idiot. This is the frame that I cannot change, so that's one segment. This is the door that sways. And then the green part is the opening, so that you can walk in and out. You got the frame that's not moving, the door that's swiveling on its hinges, and the opening. That's the triangle that I'm creating. Well, I can create infinitely many triangles right here. Because this is a triangle, opened up, that's a triangle, this is a triangle, this is a different triangle, that's another triangle, this is a triangle. So I can keep creating different ones. But the hinge theorem, put very basically, is as this angle gets bigger, What's happening to the side opposite? It's getting bigger. Well, that's what the hinge theorem says. Okay? That if you have two triangles with two congruent segments, meaning frame and door. Well, this triangle is being created now, this angle is smaller than that one. So the opening is going to be larger when this angle is larger. That's why they call it the hinge theorem. So the bigger this angle gets, the larger the opposite side gets. Okay? But in the textbook, they have to set up this situation. They have to set up this whole two triangles with two congruent sides. So it takes a little while. So we'll just go line at a time, okay? And it says, if two sides of one triangle are congruent to two sides of another triangle. That's the first statement. If two sides of one triangle are congruent to two sides of another triangle. So they're setting up this scenario that you have two triangles with two congruent segments. So if two sides of one triangle are congruent to two sides of another triangle, and the included angle, so you have and the included angle of the first is larger than the included angle of the second. The included angle of the first is larger than the included angle of the second. So right now we've got this situation. We have two triangles with two congruent sides. This is one congruent side. This is the second congruent side. And the included angle. Included means the angle that's being created by these congruent segments. So this is the included angle of those two sides. The included angle of the first triangle is bigger, is larger than the included angle of the second. If all of that happens, then the third side of the first triangle, so meaning this opposite side, that's the third side. The third side of the first is longer than the third side of the second triangle. Here's an example that I need you to copy down this diagram right here. This is an example for us to practice the hinge theorem. You have this, the whole shape is a quadrilateral, right? 1, 2, 3, 4 sides. But then I drew in this diagonal, or that segment, and it is breaking it up into two triangles. So you have triangle JMK and triangle LMK. Go ahead and draw this diagram to the best of your ability. It doesn't need to be perfect, but you have to have something to look at. And the question, and you're going to have one of these on your quiz next class, is I want you to compare segment JM and segment LM. I need you to compare their lengths. Are they equal? Is one bigger than the other? That's what I mean by comparing them. So your final answer on the quiz next class, I asked you to compare these objects. Well, you need to tell me something about their lengths. So are you going to use this notation when you talk about their lengths? No. If you use this notation talking about the lengths, you will lose points. It's way past halfway of this entire year. If you're still getting this notation mixed up, like, I'm still going to take off points. That's objects. When you want to talk about their length and compare values, you have to lose that bar. So the length of segment JM, how does that compare to the length of segment ML? What's going to go in between them? The length of segment JM is greater than. How do you know that the length of segment JM is greater than the length of segment ML? Why? Because its opposite angle is greater than segment ML's opposite angle. Yep. 64 is bigger. So since 64 is bigger, it's going to open up more, making that larger. You'll have questions like that on your homework and on the quiz next class. Okay. Now what I've been doing is we ripped out workbook pages 85 all the way to 102. We ripped those out. And this was our review for the test that we took last week. And so I let you use this review on the test. There were 3 of you who turned in this packet of paper, and there was no name on it. And so I had no idea whose it was. So there is 1, 2, 3 of them here. Doesn't have a name, doesn't have a number, doesn't have a date. The only reason I knew it was from this class is because I immediately after class I went and got them. So there's 3 of you that I have no idea whose they are. And then these folks are absent. If you know you didn't turn in one, then you still should have these workbook pages. And what I'm doing is I am taking the last 3 pages that we stapled together, I am taking them and ripping them off. And that's what I'm giving to you folks right now. Alright, so if you didn't just receive something, that means this is one of yours with no name, or you never turned anything in at all. And I never even received it. One of those 2 options. But you need to figure out where your workbook pages are. Workbook pages 97 to 102. So have those out. And I'm going to be writing the problems that we are assigned as a review for the quiz. I'm going to be writing them up here. These are the ones with no name if someone wants to come claim them. On this page, you're assigned 4 through 8. I'm just going to do some of them for you. Okay? This type of question will be on the quiz next class. List the sides and the angles in order from smallest to largest. Please make sure that you follow the instructions and that you list them from smallest to largest in this case, or maybe on the quiz next class I'll have the directions say from largest to smallest. Just please make sure you read and follow them. Number 4, we're given the side length, so it's extremely easy to list the sides from smallest to largest. I have segment DF. I'm talking about segments here, so you need the bar above these 2 capital letters. And then segment FE, and then segment DE. Extremely easy when you're given the side lengths to determine which one's smaller and larger. Now for the angles. Well, now for the angles, we're going to have to think a little bit. The smallest angle is opposite the smallest side. So the smallest side is side DF here, so the opposite angle would be angle E, making angle E my smallest side. Angle, excuse me, angle D would be the one in the middle, and the largest angle in this triangle is angle F because it's opposite the largest side, which is 14. So very simple question. Number 6, right below that's the next one I want to talk about. Now they give us the angle measurements. Then they ask us to list the angles and sides from smallest to greatest. Well, they give us the angle measurements, so that's pretty simplistic. Angle Z is by far the smallest, 37, and then angle X after that, and then angle Y is the largest, it's last. So now looking at the segment.